Let's be math translators, okay? A translator is a very important job in real life, especially between two different languages, because if you know two languages and this person over here only knows one and that person over there only knows another, but you know both those languages, you can actually be the middleman, and people get paid good money for that. Maybe not so much with math, but it is a very important skill. It helps us solve problems. It helps us figure out where we're going with certain things. So we're gonna spend some time going over how to translate from math to English and from English to math today. This is not a terribly difficult concept. It's not gonna take a terribly long time to explain this, but it is gonna take a lot of practice. So on the exercise that I give you a fair amount of practice and some problem solving. And then I give you some links down at the bottom of this whole lesson so that you can practice even more. Just like learning any language, just like learning how to translate any two languages, it takes practice, okay? So let's start with a statement. Let's start with a number plus 8. I'm going to start there. Now, before I go too much further, I want to go ahead and point out, if you didn't see it already, down underneath this lesson and underneath the exercise that comes after this lesson, I gave you a nice cheat sheet, okay? It actually has a whole bunch of keywords. For example, you know you're going to add when it says like plus, or sum, or total, or added to, or how many more, or something like that. Lots of keywords for addition. For subtraction, there's things like difference, taken away, decreased by, stuff like that. Multiplication, you might see product, you might see multiplied by. A really important one is the word of. Of, in these kinds of things, almost always means to multiply, especially if there's a fraction or a decimal or percent before the word of, like percent of, that means you're going to do some multiplication in there. 1/3 of, that's multiply. And then there's division. The biggest keyword there I think is probably quotient, divided by, equally, evenly, things like that that show that you're going to be splitting things up. So if you haven't already, you might want to open that up while you're watching this lesson, or print it out so you have it next to you, and we'll start looking for those keywords, okay? So back to my statement. A number plus 8. Now here's the thing. Whenever you see this right here, a number, that means I don't know what that number is. That's why it says number. If I knew what the number was, I would have said just like 7 plus 8, and that would have been easy. But since I don't know what this number is, I'm gonna have to assign it a variable, right? Does that sound familiar? I'm gonna have to say this number, I don't know what it is X. Or any variable you want to choose. Doesn't have to always be X. Okay? So far I've already defined what this is, and I gave it a variable. What does the word plus mean? That's pretty easy, right? That means I'm gonna add. And since I already know what this number is, all I have to do is bring it back down here. This English statement has just been translated into this math statement. Okay? A number plus 8. In English, it looks like this. In math, it looks like this. A number plus 8. See where I'm going with this? Nice, easy example there. Let's look at another one. Like I said, the best way to learn this is keep practicing and just get exposed to lots of different examples. Let's try this. What is the product of n and 8? Well, let's think about this. The product of n and 8. What does that mean? If you look on your cheat sheet down there, you'll see that the word product, and we might already know this, I hope, the product is an answer to a multiplication problem, right? So this means I'm multiplying these two. Make sense? This is my keyword to show me that n and 8 are going to be multiplied together. So there's a couple ways I can write this. You could write it just in order, n times 8. Because multiplication doesn't matter if you write things back and forth. We'll get to that when we get to the commutative and the associative properties of multiplication. You can write it backwards. That's still correct. And just like we were doing with algebraic expressions in the last lesson, you don't even have to put that dot there. You can write this as 8n. Any one of those is correct, okay? When you get more used to writing algebraically, this one will be your go-to. You'll almost always see it written with a coefficient and a variable, 8n, okay? So there's product. Let's try something else. What is the quotient of, I'm going to put it on a second line, a number and 9. This one we have to be careful with. What does quotient mean? If you look at your cheat sheet, where do you see that? What operation does quotient fit under? That's division, right? And we probably know that quotient means it's the answer. So this is basically saying what's the answer to a number and 9. We don't really care what the number is. We're just writing an expression, right? It's a quotient of a number and 9. Order matters when it comes to division. Doesn't matter with multiplication, and it doesn't matter with addition, but division and subtraction, it matters, okay? So when you see something written out as the quotient of a number and 9, that means whatever comes first is the number that's being divided, and this is what it's being divided by, okay? So we don't know what this number is. No idea. I'm going to give it, let's pick another one, a t. We don't know what this number is, so the variable we're gonna use is t. How do I show the quotient of that? Well, I know that t is the number being divided and 9 is the number dividing t. So I have a couple ways to do this. I can write it as t divided by 9. That works. Can I flip it backwards? Nope, I just mentioned that. Division, you can't do that. Okay, it changes everything. But there is one way I can write this as a fraction, because fraction just means division, right? This number is the numerator. And this number is the denominator. So either one of these is correct. And either one of these is the translation from this English statement. Okay? How about one more single operation. What is the difference of 10 and a number? Again, we have to be careful because difference tells us what? On your cheat sheet, difference is underneath subtraction. This signifies, this is the keyword that signals we're doing subtraction here. 10 we know is a number, but we don't know what this one is, so let's give it a variable. We'll use y this time. Okay? 10 and y. What's the difference of 10 and y? And sometimes you'll see it written as the difference between 10 and y. Just like division, you have to be careful of the order. So whenever you see a statement that signals the difference, you're going to use this one as the first number, this one as the second number. Okay? So what's happening here is 10 minus y. Okay? Or 10 plus the opposite of y, but we'll get to that later. 10 minus y. That's a good place to start. Good. Let's try trickier examples. I want to know, what is 5 times the sum of a number and 2? This time I have two operations. Can you see that? Here's a keyword that tells me to do multiplication. And over here, I have another keyword, sum. Sum is a keyword for addition. So I have two operations here. Okay, I know I'm gonna multiply something, so I'm gonna put 5 times. And then I know I'm gonna add these two, because this says 5 times the sum of these guys, okay? Let's go ahead and give a number a variable. We can use m. Doesn't really matter what you choose. And 2. So I know I'm going to be adding m plus 2. And 5 times m plus 2. So 5 times the sum of m and 2. That makes sense. 5 times m plus 2. Okay? And this is not totally incorrect way to write it either. However, it's more correct to make sure that this second part, the sum of a number and 2, gets its own little basket. And whatever happens in here gets multiplied later by 5, okay? Both of these are technically correct. This one is more correct, and this is the one you'll see written more often algebraically, okay? So there's a 2 operation example. How about 8 less than 4 times a number? How many operations are in there? Let's look for keywords. Less than tells me something's getting smaller, right? So that's subtraction happening there. And I also have times again, so that's multiplication. So I have 2 operations, subtraction and multiplication. So let's think about this. This says 8 less than. That means something is being subtracted by 8. Whatever I have, I'm going to take 8 away from, right? That's what this means. 4 times a number, well, that can be written a couple different ways. I'm going to use the nice algebraic expression way and put 4x. So here's 4x. That's this part. 4 times a number, right? And then let's look at the rest of it. 8 less than that. So basically it's 8 less than this. How do I show that? Well, I'm going to take this and then I'm going to subtract 8. All right? Notice there's no parentheses here. And that's because nothing really lives in its own basket here. This is a group from here, and then I take away 8. Okay? This says 8 less than 4 times a number. Okay? It takes a lot of playing around. Now let's go backwards. I'm going to give you a math statement, and let's see if we can translate it to English. Okay? How about 1/2 times x? Notice how the 1/2 is stuck to x? That's because this is a coefficient, right? And this is the variable. So this term has a 1/2 times the x. There's a couple different ways I can write this. Okay? First, I can write it as just 1/2 times x, right? Totally correct. Good for us. There's one right answer. How else could I do this? I can also write it as 1/2 times a number. Because that's an unknown, so I can just call it a number, a generic number. I can also introduce the word of here, because this can be read not only as 1/2 times x, but 1/2 of x, or 1/2 of a number. So this is where we can introduce that keyword. 1/2 of x. Okay? There's that word. Like I said, anytime you see of used in a mathematical statement, it almost always means multiplication. Okay, good? how would I translate this? This time I have x plus 5 in a basket all by itself inside the parentheses, and then I have 2 being multiplied by whatever answer it is. Okay, well, there's a couple ways I can do this. I can say 2 times, and then I have to figure out what am I going to call this. It is a sum because it's being added, so I could say 2 times the sum of x and a number, or x and 5. Or I can call it quantity. I can say, what is 2 times the quantity of x plus 5? Okay, I could say, what is 2 times the total of x plus 5? Pick something, okay? Or you can say 2 times the sum, yeah. Something that's gonna show that this is in a basket. Could I say 2 times x plus 5? No, and here's why. Because if I said 2 times x plus 5, there's nothing in here to signal that I'm going to have these two sitting all by themselves, that I have to worry about those together. So this would actually look like 2 times x plus 5. Okay, these two are not the same. Because once I finally figure out what x is, here I would add it to 5 first, and then, remember the order of operations, I would do its inside the parentheses first and then multiply by 2. Here, once I figured out what x was, I would multiply by 2 first and then add 5. And you'd get different answers, okay? So we have to be careful. This will not work. I need to signify to whoever's reading my statement that this is a sum or a quantity or somehow grouped together, okay? So I would say 2 times the sum, 2 times the answer to x plus 5. Okay, make sure that that's written so that we can tell, oh, well, that goes in parentheses, and then I'll multiply 2 by it. All right. See if I have any other examples I want to throw out there. One more. Let's leave the parentheses out this time, and let's do 7y plus 8. Okay? A couple different ways you can do this one too. That's the kind of the interesting thing about translations like this, is there's no one totally right answer. You can say the same thing, the same expression in lots of different ways. But here's one way I could do this. I could say 8 plus the product of 7 and y. And that right there tells me that I'm going to multiply 7 and y and then add 8, which is what I did, right? Product of 7 and y, add 8. Okay. What's another way? You can do it real simple. You can just read it left to right. 7 and a number plus 8. Because here we're not putting anything really into a basket. The order of operations will take care of this for us because it tells us to multiply first. So those both are correct. Can you think of other ways to do it? See if you can come up with one more way to write this expression, and then open up your exercises and try some practice, okay? When you're done with this, go ahead and move down, open up your exercise sheet, take some time on this, really think about what it's saying, and then we'll get back together on the next video and see how we did, okay?